Let's go ahead and finish up section 5.2. So we've talked about properties of the normal distribution as far as the 68, 95, 99.7 rule. I'm going to go ahead and write this down again. And remember that this is going to give us an estimate. If we want to have a better idea of the percentage of data values using values that are within 1 standard deviation, within 2, or within 3. If we want exact, we're going to have to use the table on page 370 and 371. And that will be provided for you during the exam. So let me go ahead and clear this. And then we talked about area to the left of a z-score. What I want to talk about in this video is if we're looking for percentage of data values that are greater than some given value, or percentage of data values between 2 given x's. So let's go ahead and start with greater than. What I'm going to do is I'm going to give an example here, and then we'll give a data set here, and then we're going to work through 2 examples using that data set. So let's say that we're talking about IQ scores. We know that they're approximately normally distributed. We have a mean of 100 and a standard deviation of 15. Let's say that we want to know the percentage of data values that are greater than an IQ of 88. So the first thing we need to do is we need to standardize this. We cannot work with this as is because we need an exact percentage. So we don't want to use an estimate. We don't want to use that 68, 95, 99.7 rule. We also don't know if it's exactly within 1, 2, or 3 standard deviations. So let's go ahead and turn this data value of 88 into a z-score. So we have z is equal to the data value minus the mean over the standard deviation. And we can see that our z is negative 0.80. Again, remember, we always want to round these out to 2 decimal places. So let's go ahead and sketch this. We know right in the middle is our mean. It's also where z is equal to 0. And we want to see where this z-score would lie. So since it's negative, we know it's going to be to the left of the mean. It's going to lie about here. We want to know the percentage of data values that are greater than this. So we're looking for the percentage of data values that lie to the right. Remember that the tables that we use tell us, so I'm going to write this down here. The tables tell us percentage to the left. But we know that the entire area under the curve is 100%, or as a decimal, 1. So we can see what percentage lies to the left of negative 0.80. And then we can subtract that from our total to see what lies to the right. So I'm going to go ahead and clear this screen just for a second so I can move and show the table. we're going to go ahead and use the one that talks about negative z-score, since we have a value of negative 0.80. So we can see the z-score of negative 0.8, and this first column is always the last digit is 0. The most common mistake here is that people tend to want to just circle that value and write that down. But remember that that is representing, I'm going to go ahead and clear actually. So keep in mind we're using this 0.2119. Remember that that is representing the percentage to the left. So if I have z is equal to negative 0.80, this 21.19% is the percentage of data values to the left. So if I want to find the percentage of data values that are greater than that, again, I'm going to subtract that percentage from 100. So I'm going to be left with 78.81%. Let me go ahead and clear this to do another example. Let's say here we're still working with the same IQ scores, mean 100, standard deviation 15. And now I want to see what percentage, or what is the probability of getting an IQ score greater than 133. So again, the very first thing I want to do here is I want to convert this 133 to a standard score. So I'm looking for a z-score. It's the data value minus the mean over the standard deviation. And here we end up having z is equal to 2.20. So I can see I'm going to be about here. Use a different color. Okay, so we have our z is equal to 2.20. I'm looking for the probability that it's greater than that, or the percentage of data values that are greater than that. So there's two ways that I can solve this. I can solve it the same way as I did before, where I say, okay, let's find the area to the left and then take 1 minus that value. So if we go to the table, we would see that the area to the left is 0.9861. So I'm going to subtract that from 1. And that's going to give me the remaining probability to the right of 0.0139, or 1.39%. I also can complete that another way. So remember, one of the characteristics about the curve, the normal distribution, is that it's symmetric. So if I'm looking for the area to the right of positive 2.20, since our curve is symmetric, I'm going to have the exact same area to the left of the opposite z-score. And so now I can go directly to the table and I would still see that I have that same 0.0139 value. So sometimes it might be to our benefit to use symmetry. Just a little bit easier than doing the 1 minus method, but whichever works for you. I want to move on now to looking at scenarios where we're looking between two data values. So let's look at this same data set. We have a mean of 100, a standard deviation of 15. And let's look for the probability of somebody having an IQ between 70 and 115. So again, we're looking for the probability or the percent of data values that are between this. So the first thing we need to do is we need to standardize both of those. So we need to find what is that on a z-score. So 70 minus the mean over the standard deviation. For both of those data values, 115 minus 100 over 15. And I can see now that I'm looking between -2 and +1. So I'm looking for the probability of lying in that region. It might seem complicated at first, right? But let's go ahead, and I'm going to use different colors here. Let's go ahead and find the probability of having a score less than 1. So we can go to the table and look up the probability to the left of z is equal to 1. And we should see that we get 0.8413. So that's saying 84% of the data lies to the left of z is equal to 1. Well, now, if I look up what lies to the left here, I can subtract that off, right? And I'm going to be left with just what's in between. So I have the whole part to the left minus to the left of -2. So again, we're going to go to that z-score table. We want to find what is to the left of z is equal to -2.00. And we should see in the table that we end up having a probability here of 0.0228. So that means that about 2% of the data is over here in this tail. So now to find what's between, we're going to take the 0.8413 minus the 0.0228. And we should be left with 0.8185 or 81.85%. So we can interpret that by saying 81.85% of the data is between IQ scores of 70 and 115, or we can also say the probability of having an IQ between 70 and 115 is 0.8185. let me go ahead and clear this and we'll do another example here. And we're still working with that same data set, so the same IQ, mean, and standard deviation. But now I want to find the probability of finding somebody with an IQ between 88 and 127. So again, remember that we're looking for the z-score first of both of these. Same thing here, z is equal to 127 minus 100 over 15. We should have our z values of negative 0.8 and also z-score of 1.80. And I'm looking for the percentage of data values that lie between those two z-scores. So again, what I want to find first is the area to the left of z is equal to 1.80. From the table, we should have 96.41% to the left. And I also want to find the area to the left here of z is equal to negative 0.80, which gives us 21.19%. And I'm looking for the difference, right? Because I'm looking for what is in between these two. So I'm going to take that total of 9641 and subtract off this piece over here to the left. And I can see what's left between them is 0.7522, or about 75.22% of the data. Lastly, in this section, I just want to make a mention or a recall of what it means to be a percentile. So remember that if I have a 50th percentile, what that means is 50% of the data values are less than or equal to that value. So essentially I could say, okay, right at the 50th percentile, I know that 50% of the data values lie to the left. So it's really important moving forward to be able to recognize, if we're told percentile, what that means as far as our z-score is concerned. So we're looking at the area to the left is equal to that percentile. And I do plan on doing more examples, but I'm going to end this video where we're at and then pick up more with the percentiles in the next video.